Today we will be starting with the fourth module. So in this module it will cover some topics like related to the concepts of functional and logic languages. So in first module we have seen some languages that like imperative languages or procedural languages, functional or applicative languages, object-oriented languages, concurrent programming language, logic language and scripting language. And also we have seen some example programs that is coming under each type of languages. So from this we also learned that procedural languages, it will be having some code which will be operating on the data. So code will be separately stored and data will be separately stored, and it will be operating on the data that is stored in the memory. In object-oriented languages, the object, it helps in encapsulating both the code and the data, and the computation involved will be like the objects, they interact with each other. So no separately they are not stored. An object will be encapsulating both the code and data, and the objects will be interacting with each other. So examples will be like similar, Smalltalk, C++, Modular 3 and Java. It comes under this object-oriented languages. Then pure functional languages, in which the data has no independent existence, and in which the code they helps in transferring the flow of data will be through the functions. So computation is like a function performs its operations and gives its information to the other functions. So example is like Lisp, Scheme, FP, ML, Miranda and Haskell. These are some of the languages. And here we are going to learn about this functional and logic languages, in which functional languages, first we are seeing about this functional languages. It is specifically designed to handle symbolic computation and list processing applications. Then what functional programming, it is based on the mathematical functions. So some popular functional programming languages include Lisp, Python, Erlang, Haskell and Clojure. So Lisp means list processing, and Python also you are aware of it. This languages, Erlang, Haskell, Clojure, these are some other functional languages that is being used for their own applications. So Erlang is like it can be used for real-time system applications. Like that it goes on. So logic programming, it is based on the predicate logic and targeted at theorem proving languages, automated reasoning, database applications. So functional and logic programming languages, it can be used for different applications. Functional means it will be used for symbolic computation and list processing. Logic programming can be used for theorem proving languages, and it is based on predicate logic. This can also be used on automated reasoning and database applications. So functional languages, the model of computation is the Lambda Calculus, in which it defines the outputs of a program as a mathematical function of the inputs. It doesn't have any internal state, and therefore it doesn't have any side effects also. Then it computes by applying a functional form to an argument. So it will be computed based on a functional form and will be given the values in the form of argument. programs are built by composing simple functions into progressively more complicated ones. It starts from simple to the more complicated, and recursion is a preferred means of repetition. If you need to repeat some statements, means recursion method will be the preferred one. Then examples of functional programming languages we have seen: Lisp, Hope, ML, Scheme, Miranda's Haskell, and Erlang. So their year of existence also it is being mentioned when it is being introduced. So, and it's where it is being, each programming languages, what is the specialty of each programming languages is also given. So Lisp is the first functional language, and Hope equational functional programming language, ML polymorphic typing systems, Scheme static scoping, Miranda equational definitions of polymorphic typing. So it is having different specialties for each and every language. So functional languages, it can be categorized into two, like a pure functional languages and impure functional language. Pure functional language supports only functional paradigms, for example Haskell, and impure functional languages it support functional paradigms and imperative style programming. Example is Lisp. Next, it covers some of the differences between the functional programming and OOPS languages. In which functional programming will be treated as an uses immutable data, OOP mutable data. Then functional programming follows declarative programming model, in which OOP follows imperative programming model. Functional programming focus what you are doing, and same time OOP will be focusing on how you are doing. Functional programming, it supports parallel programming, and OOPS is not suitable for object-oriented programming, is not suitable for parallel programming. In related to side effects, in functional programming it have no side effects, and in OOPS it is having serious side effects. Methods can produce serious side effects. Then related to flow controllers, flow control is done using function calls, and function calls with recursion. And in case of OOP, it will be done using loops and conditional statements. Here, function programming, we make use of function calls and function call with recursion, in which OOPS will be, it makes use of loops and conditional statements. Then functional programming, it makes use of recursion concept to iterate the collection data, and in OOPS it uses the loop concept to iterate the collection data. Then execution order of statements is not so important in functional programming. In OOPS execution order is very important, and function it supports abstraction over data and abstraction over behavior in function programming. In OOPS, it supports only abstraction over data. So, these are some of the differences between the functional programming languages and the OOP languages. So, function programming, what you are doing, it concentrates, in which the OOP concepts, it will be mainly concentrating on how it is being done. Then how the functional programming languages, it is being originated. It started with the church model of computing that is called as Lambda Calculus. Functional programming languages, it started with the church model of computing that is called as the Lambda Calculus. It was based on the notion of parameterized expressions. with each parameter introduced by the occurrence of the letter lambda. Hence the notation's name is called as the Lambda Calculus. So in case of first it started with the Lambda Calculus, that is Church's model of computing. In case of Lambda Calculus, it has parameterized expression, and the parameter will be introduced with the help of this lambda. So after this lambda, it follows with the parameter, and hence the notation, since the lambda is being used, the name also it is given as Lambda Calculus. So Lambda Calculus was the inspiration for the function programming. One uses it to compute by substituting the parameters into the expressions, and one computes in a high-level functional program by passing arguments to the functions. So how it is being implemented, we can see with the help of an example. So in Lambda Calculus, the entire thing will be viewed in the form of the expression, and value will be substituted to the variables that forms the expression, and then the result will be obtained. The final result will be obtained after performing these calculations. So computation is a sequence of expressions that result from successive evaluation of sub-expressions. So sequence of expressions it will be having, and sequence of expressions, these expressions will be having some sub-expressions also. Then the significant features of functional programming concept, like first class and high order functions, in which first class means that the programs can create new functions at the runtime, and high order function means it takes a function as an argument and will be returning a function as a result. Then second feature, implicit parametric polymorphism. As you all know, polymorphism is a significant feature in which the function will be created to accept any type of arguments. So the function can be used in general so that it will accept any type of arguments. Then it also supports powerful list facilities, and structured function returns it has, fully general aggregates, and finally the garbage collection. These are some of the features that is coming under this functional programming. Then no side effects, as we have seen, because what is the computation that is being performed, the value will be obtained, or the value will be given for display after the computation. So no side effects. It is side effects will be occurred. Functional programming, it does not support variable assignment or state mutation. The only result of functional computation is the computed value. So no additional changes will be done during the computation, and hence there is no side effects. High order functions, it takes function as an argument, or it will be returning a function as a result. So function programming requires that the functions to be first class, in which functions can be passed as an argument to other function, or it can be returned as a result of a function, or the function can be any function without names. It can be anonymous. Lambda Calculus, as we have learned, it is a form of parameterized expressions, and parameter will be known with the help of this lambda notation. Lambda Calculus was the basic model for this functional programming, and it is a framework that is developed by Church. So that is called as the Church model of computation, in which computations are studied with the functions. And pure lambda calculus, it has no built-in functions. So format for defining this lambda calculus is like this. E is equal to x, which indicates the variables, e1, e2, which indicates the function application, lambda x dot e indicates the function creation.